far beyond the familiar stars of our night sky. In a quiet region of the constellation Leo, a faint change in infrared light reached Earth after traveling for more than a century through the darkness of space. At first glance, it looked like just another data set, one more stream of numbers among trillions collected by humanity's most powerful telescope. But hidden inside that light was something no one was prepared for, a chemical signature that does not belong to rocks, oceans, or storms, but to life itself. The James Webb Space Telescope had just detected a world so perfectly balanced, so chemically alive, that scientists reached a level of certainty rarely seen in astronomy. Not a maybe, not a possibility, but a planet that appears fully habitable and potentially more life-friendly than Earth. What Webb has found doesn't just suggest life might exist somewhere out there. It suggests we may have finally found it. The breakthrough arrived quietly, buried deep inside infrared data collected as a distant planet passed in front of its star. As the starlight filtered through the planet's atmosphere, specific wavelengths were absorbed, leaving behind a spectral fingerprint. At first, scientists identified familiar molecules: water vapor, methane, and carbon dioxide. Each one was important, each one suggestive. But then came the molecule that changed everything: dimethyl sulfide. On Earth, this compound is produced only by living organisms, not volcanoes, not lightning, not chemistry alone, but life. And the signal was not weak. It was strong enough that the probability of it being a mistake dropped below 3 chances in 1,000. In a field where uncertainty is the norm, this level of confidence is extraordinary. The planet known as K2-18b orbits a red dwarf star 120 light-years away, directly inside the region where liquid water can exist. But unlike the rocky Earth-like world scientists once believed they needed to find, this planet belongs to a different class entirely. A super-Earth, larger, heavier, and wrapped in a thick hydrogen-rich atmosphere. And instead of making it hostile, that atmosphere may be exactly what makes it ideal for life. K2-18b is not balanced on a knife's edge the way Earth is. Its environment appears remarkably stable. The planet's surface temperature hovers around 120 degrees Fahrenheit, warm enough for liquid water, yet cool enough to prevent oceans from boiling away. This temperature is not accidental. The hydrogen-rich atmosphere acts like a planetary blanket, trapping heat and distributing it evenly across the globe. Unlike Earth, where temperatures swing between day and night and between summer and winter, this world may experience consistent planet-wide conditions. Even the night side, locked in permanent darkness due to tidal locking, remains warm enough to sustain liquid water. Gravity plays a crucial role here. With nearly 3 times Earth's surface gravity, the planet holds onto its atmosphere with ease, preventing it from escaping into space like Mars did billions of years ago. What seems extreme to us may actually be an advantage. Strong gravity, a thick atmosphere, and stable temperatures together create an environment where life does not need to constantly fight for survival, but can instead focus on growth, complexity, and evolution over enormous time scales. The star hosting this planet is a red dwarf, smaller and cooler than our Sun, but far more enduring. While our Sun will eventually expand and erase all life on Earth, red dwarfs burn steadily for trillions of years. That means any life that emerges on a planet like K2-18b has virtually unlimited time to evolve. The planet completes an orbit every 33 days, sitting close to its star, yet receiving almost the same amount of energy per square meter that Earth receives from the Sun. This places it squarely in the habitable zone, but with one crucial difference. The habitable zone around red dwarfs lasts far longer than around stars like ours. Add to that the planet's thick atmosphere, which shields the surface from harmful radiation and redistributes heat globally, and you begin to see why scientists are rethinking everything they believed about habitability. This discovery suggests that Earth-like planets may not be the best places to look for life after all. Instead, the universe may favor worlds that are bigger, warmer, and far more stable than our own. What truly elevates this discovery is not just the planet's location or temperature, but the behavior of its atmosphere. The detected gases exist in a state of chemical imbalance. In a lifeless world, these molecules would react with each other and disappear. Yet they persist in large quantities. On Earth, this kind of atmospheric disequilibrium is maintained only by biological activity. Life constantly pumps gases into the atmosphere, preventing it from reaching chemical equilibrium. K2-18b shows the same pattern. The absence of ammonia, a compound expected in lifeless hydrogen-rich worlds, strengthens this case even further. Something appears to be actively removing it. Something alive. If this interpretation holds, then we are not observing a planet where life might exist someday. We are observing a planet where life is already shaping the environment on a global scale. A living world breathing across interstellar space, detectable from 120 light-years away. For decades, the search for life beyond Earth followed a rigid blueprint.